All right, in today's video, we're going to look at using arrow diagrams to write the inverse of a function. It's going to involve using several things that we already know about the arrows. But since this is all based in composition, and composition so naturally linked to the idea of inverse, then arrow diagrams become a very good way of doing this. So we're going to start by building the arrow diagram for the function that we have. It always starts with our independent variable x. And the first thing that we need to do to the x is sign change that so we get it to be a negative x. We'll write the intermediate steps here for the time being. And then we will add 1 onto that. And that would give us the 1 minus x. We then need that 1 minus x in the denominator, so I show that with a reciprocal function looking like that. That would be our parent function in this case if we were talking about transformations. That will give us the 1 over 1 minus x. We then need to multiply by 2 to give us a 2 over 1 minus x. And then we're going to sign change again, another reflection that would be happening here. So negative 2 over 1 minus x. About that, get rid of that. And then finally adding 3 on would get us to the 3 minus 2 over 1 minus x. So kind of kept track of these things along the way across the bottom just to make sure that we were building things correctly. I'm going to get them out of the way right now for what it is that we're going to do. Because as we know, the inverse of a function is the thing that's going to take our y values back to the x values that it began with. So just like we would in this traditional method of this, we're going to switch the roles of the x and the y. And we're going to take the x off of this side, and we're going to start with the x over here, and we're just going to work it back to the other end. So we do inverse operations on the arrows coming back. The inverse of adding 3 is subtracting 3. The inverse of changing a sign is changing a sign. The inverse of multiplying by 2 is multiplying by 1/2, multiplicative inverse. The inverse of the reciprocal is the reciprocal. The inverse of adding 1 is subtracting 1, and the inverse of a sign change again is the sign change, and that should get us all the way back down to the other end. So now all we need to do is start with this x down here, and one step at a time we'll follow the arrows and do what it tells us to do. So start with the x. It says subtract 3 from that x, change the sign on that whole thing, multiply by 1/2, and now we're going to need to flip that whole thing over, so we could write that as a number of different ways. I'll go with a negative 2 over x minus 3. We're going to subtract 1 from that, and then we need to change the sign on that whole thing. So simplifying, that would give us a 2 over x minus 3 plus 1, and that should be our inverse function. And so the inverse is 2 over x minus 3 plus 1. Normally at this point, in a traditional approach, you would say, well, compose f of x with f inverse of x to prove that you've actually found it. So if we wanted to do f of f inverse of x to show that that comes out to just be x, but the arrow diagram does that. If we want to do the f inverse first, it means we're going to start over on this side and follow the arrows along one at a time in what it says to do to build the f inverse. And then we follow the arrows back again, since this direction all the way to here, that is our function f. And it, one at a time, undoes all of those things we did and takes us back to the x. If we wanted to show the f inverse of f of x equals x, then that just starts at the beginning because we do the f of x first, and we start over on the left-hand side over here, and we'll work our way back over to the right to build the f, and then run it from right to left back through there. So it kind of is a self-proving approach. And in another video, we'll look more specifically at composition and how we can do composition with the arrow diagrams as well. But that is it for this one.